Good morning, guys. Good morning to all. Today we are going to discuss about topology. We have different topologies in modern network world. See, I'll show you that. We have bus topology, we have star, ring, tree, mesh and hybrid. So in these topologies we use only three topologies: star, tree, mesh. Star and tree use in LAN side and mesh topology use in WAN side. So let us move to next slide. We discuss bus topology there. This is bus topology. It look like this. We have a backbone cable here. You can see that. See, here we have a backbone cable. It's a centralized cable and all the devices are connected to this backbone cable, and in this backbone cable we have a T connector. You can see here it look like this. This is the T connector. And each and every device would have a connector, this one, to connect to this backbone cable. And we have a terminator here. You can see both ends. We will have a terminator. It look like this. See, in this topology, it's the speed which get is 10 Mbps. We get the speed 10 Mbps. And here troubleshooting is also very difficult. See, if something happen in this section, all the device will not be communicating. See, if cable damage here, so that you cannot send the data from here to here, it's not possible because of this cable problem. So the troubleshooting is very difficult to find out the issues in this case, and it is very costlier. This is bus topology. Let us move to next topology, which is star topology. Here you can see that all the device connect to a centralized device. It's known as, this centralized device is known as switch. And you can see here, I'll draw some device here. See, devices are connecting to this switch. So if suppose no devices are communicating each other, so the problem would be in this device. We can replace this device within 5 minutes. And suppose some cases the only this device is not communicating to others. In this case the problem would be here. So in star topology, troubleshooting is very easy, and the speed which get is 100 to 1000 Mbps. and the cable which is used to connect from devices to switch is twisted pair cable, and both end of this cable would have RJ45 connector. Okay, so one more thing I can explain you. See, here we have multiple port, right? In this port would be all the port will be connected to a centralized point, so that it creates a star topology. And we move to next slide. It's ring topology. See here, logically it look like this, but physically it doesn't look like this. We have sender, receiver, sender, receiver, sender, receiver, sender, receiver, sender, receiver, and each device would have a MAC address A, B, C, D and E. Suppose A need to send data to C. It sends the data in clockwise direction. Okay. So, and there is a concept of token also. Suppose A send data to C. So data A to C. Data will be reaches to B. B will check the destination address. It is C, so it forward to B will forward this data to C. So C will check the destination address. Yes, it's for C, and C will accept that, and C will give the reply. It also, the data will travel in clockwise direction. It will send to D. D will send to E. E will send to A, because the destination address is, I will show you that from C to A acknowledgement. So C will give the reply, right? So source address will be C and destination will be A. It reaches to D, then it E, then to A. So when someone is sending data in this network, no other can send at the same time, because token is already in use. If token is free, anybody can send data. And physically it look like this. We have a MAU device. It's known as, like, we have a device, multi-access unit, MAU, MAU, and we will have multiple port here. Device will be connected like this. So this port, suppose this is one first port, second port and third port. First would be connected to second, second would be connected to third, third would be connected to one. It forms a ring, right? You can see like this. But in the case of switch, it forms star on. I have shown you in the previous slide, right? So this is the ring topology, and this also not in use. Now we move to next slide. Okay, tree topology. See, in small network we use star topology. We can use star topology in larger network also, but the problem is we have 1,000 device. Suppose we have 1,000 devices. So to connect these 1,000 device, we need at least 20 switches, right? Switch 1, switch 2, switch 3, etc, etc. This is 20th switch, and devices are here, device here, here, here. We have 1,000 devices. Suppose we have 1,000 devices, and all the devices are connected to the switches. Suppose, so in this room, if we connect 1,000 devices to this room, so 1,000 cables would be there. So if something happen in this device or in this network, this device is not communicating to others. So we have to identify the cable. We have to identify this particular cable from 1,000 cable, right? So it's very difficult to troubleshoot. If we use star topology in larger network, it is very difficult to troubleshoot. That is the main problem. So to overcome this issue, tree topology came. See, in tree topology, suppose we have a flow here and it's divided by 2. We have flow here, it's also divided. We have another flow divided, and multiple devices have in each flow. And we have a switch here connected here. Switch here. Second floor also same thing. Switch here. All the device connect to this switch, and same here also we have multiple devices. And this device are connected to this centralized device here also. Centralized device. And see, both this block would be interconnected through another switch. Here also we have one more switch to connect this multiple block. We have one more switch here to connect this multiple block, and we would have one switch here, and this switch would be connected here, this would be connected here, and this will be connected here. So it forms a tree, right? So troubleshooting is very easy. See, if something happened in this section, you just want to look in this switch and we can find out the problem. Suppose if this device is not communicating to this device, so we can check this area. or all this device is not communicating to this section, you can check this switch, right? So we can easily identify the issues. If flows are not connecting, we can identify the problem from this side. So troubleshooting is very easy in this case. Tree topology. And the next topology, which is mesh topology. Mesh topology look like this. It's a logical view, and physically I will show you that. We have a branch here. Suppose we have a Bangalore location, we have a branch here. We have multiple devices, and which would be connected to a centralized device. And suppose mention this as Bangalore. Now we have a branch in Chennai, and we have multiple PC here, and it connects to a centralized device switch. And we have another branch in Mumbai. We have multiple devices are there, and it connects to a centralized device. We have another branch in Cochin. We have multiple devices. Also a centralized device here. All the devices are connecting here. And everywhere, see, this branch would be connected to a ISP. This branch would connected to another ISP in Chennai location. This branch would be also connected to another ISP in Mumbai. This one would be in Cochin. So ISPs are already interconnected to each other. It would be like this. Sorry. It would be like this, like this, like this, like this. See, here you can see that it forms a mesh, right? This is the mesh topology, and cable which used in this topology, it's a fiber optic cable. So this is the mesh topology. Mesh topology normally used in WAN side. This is WAN network, WAN side. LAN network, we use star topology in small LAN network, and tree topology in large LAN network. And the last topology, which is hybrid topology, in this we have combination of multiple topologies: star topologies, ring topology, and a bus topology. See? But these topologies are also not in use, because bus is not the, ring is not the. So this is what we called as hybrid topology. Thanks for watching. Bye.